Welcome back, and in this lesson I'm going to be discussing EBS snapshots. So snapshots provide a few really useful features for a solutions architect. First, they're an efficient way to back up EBS volumes to S3, and by doing this, you protect the data on those volumes against availability zone issues or local storage system failure in that availability zone. And they can also be used to migrate the data that's on EBS volumes between availability zones using S3 as an intermediary. So let's step through the architecture first through this lesson, and then in the next lesson, which will be a demo, we'll get you into the AWS console for some practical experience. Snapshots are essentially backups of EBS volumes which are stored on S3. EBS volumes are availability zone resilient, which means that they're vulnerable to any issues which impact an entire availability zone. Because snapshots are stored on S3, the data that snapshots store become region resilient, and so we're improving the resiliency level of our EBS volumes by taking a snapshot and storing it into S3. Now, snapshots are incremental in nature, and that means a few very important things. It means that the first snapshot to be taken of a volume is a full copy of all of the data on that volume. Now, I'm stressing the word data because a snapshot just copies the data used. So if you use 10 GB of a 40 GB volume, then that initial snapshot is 10 GB, not the full 40 GB. The first snapshot, because it's a full one, can take some time depending on the size of the data. It's copying all of the data from a volume onto S3. Now, your EBS performance won't be impacted during this initial snapshot, but it just takes time to copy in the background. Future snapshots are fully incremental. They only store the difference between the previous snapshot and the state of the volume when the snapshot is taken. And because of that, they consume much less space, and they're also significantly quicker to perform. Now, you might be concerned at this point hearing the word incremental. If you've got any existing backup system or backup software experience, it was always a risk that if you lost an incremental backup, then no further backups between that point and when you next took the full backup would work. So there was a massive risk of losing an incremental backup. You don't have to worry about that with EBS. It's smart enough so that if you do delete an incremental snapshot, it makes sure that the data is moved so that all of the snapshots after that point still function. So each snapshot, even though it is incremental, can be thought of as self-sufficient. Now, when you create an EBS volume, you have a few choices. You can create a blank volume, or you can create a volume that's based on a snapshot. So snapshots offer a great way to clone a volume. Because S3 is a regional service, the volume you create from a snapshot can be in a different availability zone from the original, which means snapshots can be used to move EBS volumes between availability zones. But also, snapshots can be copied between AWS regions, so you can use snapshots for global DR processes or as a migration tool to migrate the data on volumes between regions. Snapshots are really flexible. Visually, this is how snapshot architecture looks. So here we've got two AWS regions, US East 1 and AP Southeast 2. We have a volume in availability zone A in US East 1, and that's connected to an EC2 instance in the same availability zone. Now, snapshots can be taken of this volume and stored in S3, and the first snapshot is a full copy, so it stores all of the data that's used on the source volume. The second one is an incremental, so this only stores the changes since the last snapshot. So at the point that you create the second snapshot, only the changes between the original snapshot and now are stored in this incremental. And these are linked, so the incremental references the initial snapshot for any data that isn't changed. Now, the snapshot can be used to create a volume in the same availability zone. It can be used to create a volume in another availability zone in the same region, and that volume could then be attached to another EC2 instance. Or the snapshot could be copied to another AWS region and used to create another volume in that region. So that's the architecture, that's how snapshots work. There's nothing overly complex about it, but I did want to cover a few final important points before we finish up. As a solutions architect, there are some nuances of snapshot and volume performance that you need to be aware of. These can impact projects that you design and deploy significantly, and this does come up in the exam. Now first, when you create a new EBS volume without using a snapshot, the performance is available immediately. There's no need to do any form of initialization process. But if you restore a volume from a snapshot, it does the restore lazily. What this means is that if you restore a volume right now, then starting right now, over time, it will transfer the data from the snapshot on S3 to the new volume in the background. And this process takes some time. If you attempt to read data which hasn't been restored yet, it will immediately pull it from S3, but that achieves lower levels of performance than reading from EBS directly. So you have a number of choices. You can force a read of every block of the volume, and this is done in the operating system using tools such as DD on Linux, and this reads every block one by one on the new EBS volume, and it forces EBS to pull all of the snapshot data from S3 into that volume, and this is generally something that you would do immediately when you restore the volume before moving that volume into production usage. It just ensures perfect performance as soon as your customers start using that data. Now, historically, that was the only way to force this rapid initialization of the volume, but now there's a feature called Fast Snapshot Restore, or FSR. This is an option that you can set on a snapshot which makes it instantly restore. You can create 50 of these fast snapshot restores per region, and when you enable it on a snapshot, you pick the snapshot specifically and the availability zones that you want to be able to do instant restores to. Each combination of that snapshot and an AZ is classed as one fast snapshot restore set, and you can have 50 of those per region. So one snapshot configured to restore to 4 availability zones in a region represents 4 out of that 50 limit of FSRs per region, so keep that in mind. Now, FSR actually costs extra. Keep this in mind. It can get expensive, especially if you have lots of different snapshots. You can always achieve the same end result by forcing a read of every block manually using DD or another tool in the operating system. But if you really don't want to go through the admin overhead, then you've got the option of using FSR. Now, I haven't talked about EBS volume encryption yet. That's coming up in a lesson soon within this section, but encryption also influences snapshots. But don't worry, I'll be covering all of that end-to-end when I talk about volume encryption. Now, snapshots are built using a gigabyte month metric. So a 10 GB snapshot stored for 1 month represents 10 GB month. A 20 GB snapshot stored for half a month represents the same 10 GB month, and that's how you build. There's a certain cost for every gigabyte month that you use for snapshot storage. Now, just to stress this is an awesome feature specifically from a cost aspect, is that this is used data, not allocated data. You might have a volume which is 40 GB in size, but if you only use 10 GB of that, then the first full snapshot is only 10 GB. EBS doesn't charge for unused areas in volumes when performing snapshots. You're charged for the full allocated size of an EBS volume, but that's because it's allocated. For snapshots, you're only billed for the data that's used on the volumes. And because snapshots are incremental, you can perform them really regularly. Only the data that's changed is stored, so doing a snapshot every 5 minutes won't necessarily cost more than doing 1 per hour. Now on the right, this is visually how snapshots look. On the left, we have a 10 GIB volume using 10 GIB of data, so it's 100% consumed. The first snapshot, logically, will consume 10 GIB of space on S3 because it's a full snapshot and it consumes whatever data is used on the volume. In the middle column, we're changing 4 GIB of data out of that original 10 GIB, so the bit in yellow at the bottom. The next snap references the unchanged 6 GIB of data and only stores the changed 4 GIB. So the second snap only bills for 4 GIB of data, the changed data. On the right, we've got 2 GIB of data that's added to that volume, so the volume is now 12 GIB. The next snapshot references the original 6 GIB of data, so that's not stored in this snapshot. It also references the previous snapshot's 4 GIB of change data, that's also not stored in this new snapshot. The new snapshot simply adds the new 2 GIB of data, so this snapshot only builds for 2 GIB. At each stage, a new snapshot is only storing data inside itself which is new or changed, and it's referencing previous snapshots for anything which isn't changed. That's why they're all incremental, and that's why you only build each time you do a snapshot for the changed data. Okay, that's enough theory for now. Time for a demonstration. So in the next demo lesson, we're going to experiment with EBS volumes and snapshots and just experience practically how we can interact with them. It's going to be a simple demo, but I always find that by doing things, you retain the theory that you've learned. And this has been a lot of theory. So go ahead, complete this video, and when you're ready, we can start the demo lesson.